Hello and welcome to the week 9 extra exercises walkthrough video. This week we're taking a look at how we can do some error checking and catching in MATLAB. So we'll be looking at things like the assert function and try catch blocks. So hopefully you enjoy it.
So we'll start off with errors and warnings. So exercise 1 asks us to write a function called divide that takes two parameters, numerator and denominator, as inputs. Then it needs to do a few things. Firstly, it needs to check if the denominator is equal to 0, and if it is, it needs to throw an error message that says cannot divide by 0. And we'll be doing that with the actual error function. Next up, it'll check if the magnitude of the numerator is less than 10 and the magnitude of the denominator is greater than 10,000. So if this happens, it's going to show a warning that says result is very small. Basically just to warn the user that the output might not be as expected. I've kind of chosen these thresholds a bit arbitrarily. You probably, you could do a bit more comprehensive checking of whether something was going to be small, but for now, this is what we're going to do. And then after all that, we're going to actually divide the numerator by the denominator and display the result. So then we'll test it using a few different numbers to check that it's working effectively. So let's head over to the editor. I've already saved this file as divide. So I'm going to create a function divide that takes a numerator and denominator. I'm going to then check for the error condition. So check for denominator equals 0. So if denominator is equal to 0, I'm going to use the error function to say cannot divide by 0. And then end that. Next, I'm going to check my warning case, so check for very small result case. So if numerator, the magnitude of the numerator, so the absolute of the numerator is less than 10, and the magnitude of the denominator is greater than 10,000, then we would want to go warning this time. Result is very small. And then after all that, if we've survived to here, we actually want to get the result and display it. So we're going to display numerator divided by denominator. And end off our function. Okay, so I'm going to run this to make sure I'm in the right directory and save it. Cool. Let's try a few test cases. Let's start off with something nice and simple. Let's see if it can divide 10 by 2. There we go, we get our result of 5, so far so good. That's the case where nothing's gone wrong. Let's have a look at the case of dividing by 0. There's our error message. So it's gotten to that first block and it's checked that yes, the denominator does equal 0, and it's thrown the error message here, which has generated the angry red text that tells you what line the error occurred on. And it also made that lovely dinging sound that I'm sure you're all sick of after writing code for a semester. So next up, we'll test our very small result case. So I'll give it a 1 and some large number there. So then we get our warning, result is very small, and we actually do still get the result though. So that's the difference between error and warning. Error is your angry red text, big dinging sound, whole program fails, and it tells you what line it failed on. The warning is a slightly less angry orange text. There's no loud noises going on. It still gives you a line number. It still shows you like your message, your warning message in this case, but it allows the program to continue running. So in this case, it doesn't fail in the warning. It continues to run and it does still display the result. It just warns the user that that result is very small, so there might be rounding errors and stuff like that. So effectively, if it's not something that's going to cause your program to fail, but it might cause some like unexpected output, or perhaps it's not what the user was looking for, you could use warnings there to give them that indication. So that's errors and warnings. Next up, we're looking at the assert function. So assert is an alternative to error to handle simple logical checks. So it has slightly different syntax. It's kind of a one-line shortcut. So what I'm going to do is I'm going to comment out this code. So, and I'll just underneath it add the assert line. So we can go, the function is called assert. The first parameter is a conditional check. So you check, in this case, we want to check if denominator is not equal to 0. So the reason we check whether it's not equal to 0 is because the second parameter is the message that will display if that is false. So effectively it's saying if the denominator is not equal to 0, continue to run the code, otherwise display an error message. So if this condition here is false, then this error message will print out. So it's a little bit like, it's kind of the opposite logic to what we did up here. So up here we checked if it was equal to 0 and then threw the error. Here we're checking that it's not equal to 0, and if that's false, then we throw the error. So you're checking that it's going to work, I guess, rather than checking whether it's not going to work. So yeah, you're looking for the case where it will work and throwing an error if it won't. All right, so this is actually going to show the exact same performance. So just press play to save it. Let's see everything from before still working. Our 10 divided by 2 case returns the expected result. A very small case returns the expected result with a warning and all. And now if we do 10 divided by 0, we get that cannot divide by 0 message that we had here. So yeah, that's an alternative for simple like conditional checks. You can use that sort of one-line shortcut for that. Cool. Next up we have try-catch blocks. So try-catch blocks are for handling exceptions. Effectively, you put some code that you want to try in the try block. And if anything goes wrong, then there's the catch block that can handle the case where something's failed. So effectively, the advantage of this is it allows your program to either fail with grace. So instead of red text, loud noises, etc., you can have sort of a more descriptive failure or something like that. Like you might say, sorry, user, you've input the wrong things and that's why I'm failing. This is why you've done this kind of thing. And the other thing you can do with it is you can actually try to recover from that and continue with the program. So for example, you could set some default values and continue running. So in this case, we're going to write a function called add that takes 2 numbers as inputs and returns a result. So within the try block, we're going to attempt to use the sum function to add together those 2 numbers. Because the sum function can only handle numerical inputs, an exception will occur if there's non-numerical inputs provided. So we'll then use the catch block to handle that case. So we want to display a warning message to the user and set result to -1. So let's open up a new file. Function result equals add num1, num2. So in this case, we are in the try block. We're going to try and set result to the sum of num1 and num2. And if that fails for whatever reason, then we're going to handle it by displaying a warning message, 1 or more invalid inputs, result set to -1. So just a default value. And then we're going to set result to -1. And we'll end that all off. And we'll save it as add. And we'll head over into here. So add. Let's try some numbers. Let's go 1 and 2. And then we get an actual result. 9 and 8. We'll get an actual result. A and 9. Undefined functional variable A. Yeah, I probably should have done that as a character because it was looking for a function. So in that case, it's actually worked because that's being converted to ASCII. And therefore it still adds. But if I made it a string, then we would actually see our warning. So here it's actually treated as a number because it gets converted to the ASCII equivalent, which is 97 for A. That would make sense because that's 106. But in this case, we've tried to add a string. So it says 1 or more invalid inputs, results set to -1. I guess probably the same thing would happen if I put in just about any other string here. So yeah, that's working fine. I imagine if I put like a cell array there too, yeah, it throws a similar error. So 1 or more invalid inputs, results set to -1, and it returns -1 as the answer. So yeah, with this case, it's not actually handling this case where it's a character because characters are represented as numbers, but it'll handle a case of like strings or cell arrays or other sorts of non-numerical data. So that's a try-catch example. So effectively, it tries to do the thing, if there's any issues here, so if the sum function causes an error, then it'll catch that error and display a warning instead. So if I didn't have that, you would just get angry red text here. So that's the difference really. The other thing I might quickly run over is adding documentation to a function like this. So this is something that is part of the criteria for each assignment, but is also something that regularly gets missed. So part of the criteria is that you document your code, and that includes actually documenting your function. So documenting your function, we did touch on it a little bit a couple weeks ago, but it's effectively the process of describing your function. So in this case, you would say add, adds two numbers together, and returns the result. So that's like your one-line description of what add does. Next line down, you would actually give it a little bit more detail. So result equals add num1, num2, adds num1 and num2, returning the result. Something like this. It doesn't need to be exactly this. You might also want to give a little bit of info about how it handles an invalid case. So if either input is invalid, the function returns a default value of -1. So it tells you exactly how it works. And then you'd have your standard documentation showing what the code's actually doing. So try to add num1 and num2 together. And then catch condition, you might have something like handle any errors that result by displaying an error message and setting a default value. So the benefit of this is that when we head over to here and now type help add, it actually tells us how add works. So it gives us that one-line description followed by the usage of the function. So this is handy because if you've got a much more complex function, it just allows the end user to actually see how your function works without needing to know the details behind it. In the same way that if you typed help assert, you would get all the different ways that assert can be used and how it works. So this is the one that we used before, for example. So effectively, you're just doing this for your own function. So there's a little bit of a sidetrack. I just wanted to go over that because documenting the function is something that a lot of people missed in assignment 2. So yeah, just something to be careful of when you're going into assignment 3. Okay, so our last exercise is on testing functions. So we've touched on this a little bit just by testing manually. So, you know, trying lots of different values and stuff like that. You can also do it as a function, so you can automatically test several cases. The benefit of that is that if you have a sort of a list of known cases, you can sort of test different implementations of the same function. So for example, if you updated the add function to include more robust error checking or something like that, it would be a little bit easier to adapt it using a testing function. So I'm going to create this function. I probably should read the task first. It's asking us to write a function check add that tests whether the add function from exercise 3 is working. So it should take two numbers, the expected output, and an error message as input parameters. So if the two numbers don't actually add up to match the expected output, then we should see an error message. So let's have a look. We'll go function check add num1, num2. What else do we need? An expected output and an error message. So you'll remember from our earlier weeks, we shouldn't do direct comparisons between two numbers because, like, for example, 0.1 plus 0.2 does not equal exactly 0.3 as far as MATLAB is concerned due to the floating point errors. So we set a small threshold. I'm just going to set it to, let's say this. Yeah, you might want to play around with that threshold yourself to get something a little bit smaller, up to you. And then we're going to check if the absolute result of adding num1 and num2 minus the expected output is greater than the threshold. So what this says is it says add number 1 and number 2, subtract the expected output. If that is greater than the threshold, then there's been an error. So then we display the error message. We could do that as an error. We could do that as a warning. For now, I'm just going to display it. So then to actually use this function, we would have a series of like check add calls. So we could do it in the same file, but I'm going to actually do it in a separate script. So I'll save check add, and then in a new script, I'll call it a few times. So check add 1 and 2 as numbers would give an expected output of 3. If that fails, then we should get 1 plus 2 failed. Check add 1a, it should give us a result of -1 because that should trigger the error condition. So 1 plus a has failed if that doesn't occur. We might also check a negative case. Let's go -30 and 10. If that doesn't equal -20, then -30 plus 10 has failed. So this is the error message that we'll see in that instance. And I don't need an end statement because this is a script. Test check add. All right, so if I then run this function, what have I done wrong? I'm guessing it's probably something in here. Oh, no hat, I don't think. Yep, cool, that seems to fix it. Oh, so it hasn't actually displayed those results. Did I not have a display statement in here? Okay, yeah, it did. So that worked basically. So this should only display if there's an error. So in other words, if I stuffed something up in here, if I said, I don't know, let's say I said plus, oh, hang on, not this one, in the actual add function. So if in here I stuffed something up, let's say I did, let's say I forgot my square brackets. So if I forget my square brackets, it'll basically just return the num1. So if I then saved this and ran it, then you would actually see that 1 plus 2 failed and -30 plus 10 failed. The other one still worked because the error handling was working. So these two cases have failed. So then you could go back in, you could work out what's happened, you'd realize that you've missed your square brackets, add them back in, and away you would go. Cool. So hopefully that makes sense. This is our function. This is our function that will check that function, and this is just a script that's running that check add. So you could have also just put that above, like you could just write that above here and make it a local function. Cool, so that's testing stuff. Last exercise was all theory. So I'm not actually going to run through this in the video because it'll just be me reading stuff off a page. But I do have all of the theory questions done up as answers. I'll upload this written solution as well so that you can flick through that. So they're all there, refer to the written solution for that one. And if you have any questions, just let me know. Otherwise, that's us done for this semester in terms of our extra exercises. So good luck with the rest of assignment 3 and with quiz 2, and I will see you around. Thanks for tuning in this semester.